You should say, so they told me. Hopefully everybody's here for Can't We All Just Get Along? My name is Erik Peterson. I work at Acquia, Eporama, basically everywhere. This talk is not about how to use Git. I'm going to do some things that may familiarize yourself. I hope that most people have, typed the word Git into a command line or have tried to make a commit or looked at things like that. If you haven't, follow along. Please ask questions. I don't mind talking about some of those things. What I hope to get out of today is the idea that some of the things I'm going to show you, you will never do. You will never have to do. I never do them outside of this presentation. But it helps to dig in to see what's actually happening when you type Git and what it's actually trying to do for you. It helped me when I first saw this type of talk given. It helped me understand, how to fix things when they break, because I know what just happened. I don't ever have to do it the way I'm going to show you, but there it is. This structure, how I'm going to do it, how I'm going to go through some of these processes, totally cribbed from Tim Berglund's talk. He was a trainer at GitHub. He's since moved on to do other things, but he has some really good insight into Git. He's pretty knowledgeable, being one of the senior trainers at GitHub. YouTube here, I'm going to put these slides up on the NetCamp sessions page once we're done, just to make sure if I say anything different, I can change them before they go up. So don't try and write down that YouTube link, it's not worth it. Let's see. I'm going to run through a bunch of slides. Most of what I'm going to be doing that's interesting is actually command line stuff that's not a slide, and so we'll jump into that. I have an old Git talk about how to get started in Git that I'd spend the 45 minutes talking through. I'm going to breeze through that in about 5 or 10 minutes just to get us all on the same kind of page. I like interactive talks. In other words, I'm going to be doing things interactively on my computer, but I also like interacting with you folks. So if you have any questions, if you want me to answer something, I may defer you, but I'd like you to ask so that I can, it may be helpful. That way I have no idea when my talk will end. I usually end up going right up to the end, which is fine. But feel free to interrupt or ask questions as we go. Getting started, if you're on a Mac, if you're on a Windows machine, I have no help for you. I don't understand if you're on a Mac or if you're on Linux. You probably know how to install Git. Mac actually comes with it, but I would suggest doing Homebrew. Homebrew just helps make a lot of things easier to keep updated. There's other talks and other sessions, not today, but YouTubes and things about how to keep Homebrew, keeping lots of things happy, different versions of PHP, Git, all the packages you need. Usually on Linux, you're just doing an apt-get or a yum type of install where the packages are being managed for you. That's great. Setting up Git is trivially easy. You just need to tell it who you are. You'll notice in here that there's a -- global. That puts folder or files in your home directory, a .git config file that is really interesting to read sometimes because a lot of things you do get written into that file that you didn't know happened, and it helps figure out what Git is doing. If we have a little time at the end, we can take a peek at some of the things that I've put in mind to make Git easier. When you start with Git, if you're starting fully from scratch, you're either usually getting somebody else's stuff to work on, but if you're starting from scratch, you use the phrase init and the repo you want to initialize. And that's it. And then you're running with Git. Yeah. What did it do, though? That's what I really want to talk about today. What does the Git init and the Git commit and the Git checkout and all, what do those things do? How are they storing? What are they building up for you? To talk about that, a little bit of what you need to know is what Git tries to keep track of. And basically it has two things, objects and files. And the objects are broken down into blobs, trees, and commits. And I think of those as a blob is the book on the shelf. A tree is the directions on how to get to that book on the shelf, or the the Dewey Decimal number. You know how to find something in the library because it's got that number. And the commit is the card in your library catalog, so that you can see this thing that you want is at this has this tree and contains all of these things. So it kind of combines the other two, but it is its own object. And we'll take a look at these more in detail. Don't expect that to totally click, just from that description. The other things that Git has are what are called references, or refs. And really, the only two that we tend to talk about are heads and tags. And it's really just a way to describe various commits and their pathing. Git likes to think of itself as a tree, and you have branches. That's the newer term. What Git started out with was heads. In other words, it was more like a hydra, so it had lots of heads poking off of it, but I think trees were a little bit easier for people to understand. The good thing is a tag is nothing more than a named commit, and a branch is a commit or a line of commits that you can keep going. If we think about it in terms of a tree, pointing to this piece of bark, that's the tag. Pointing to the bud at the end of the branch, that's the branch, and what we call the head of the branch. Because as the seasons go by, that is going to no longer be the head, but that branch will keep going. So wherever you are at the tip, that's currently the head of the branch. But all those things together make up the branch from where it changed. And most of these things are broken down, since text files are image files. They're big. We don't want to deal with them, in their entirety. We use a SHA-1 hash identifier, which means it basically just figures out a short way, kind of like a bit. Think of it like a bit.ly for your file. It shortens it so that it's a unique set of characters that Git can say definitively, this structure, whatever it is that I've got, you can refer to it by these set number of characters. I don't want to say how many because I just forgot how many it was. Some number of characters, it's like 30 or 24 or probably 32. When you start in Git, usually you have a set of files that you're working with. That's your working directory. So not your whole computer, not my files, but this one project has a Git folder. And we talk about that, and we usually say the Git folder or the project folder, but that's really where you've taken all the things from Git and you're seeing a representation of them. So we think of them as the actual files. It's the working directory, the directory you're working out of. The repository, however, is what we often think of as the Git folder, or these terms get a little bit interchangeable, so that's why I want to be clear when I say working directory, when I say repository, those tend to bundle up together to make the Git thing work in an entirety. It's a hidden folder so that you don't get confused by it or delete it by accident. So .git. If you're used to working in the Finder or other methods, you may not ever see it. You may not ever look in it. You probably don't even sometimes know it's there. But this is where all of those objects, the blobs, the commits, the reference things are being stored. And it's kind of the side notes for everything that you're doing. And that is what, when you send to GitHub or a remote, and we can talk, I'll probably go through a little bit of that more. You're not sending all of your files to a remote, to GitHub, to Acquia, to Pantheon, whatever you're doing. You're sending just the objects and commits and hashes up to the Git repository, because that's all it needs. Now the object, I said it's broken down to just being a hash that identifies it. That's the name. It still is the whole contents underneath, so when you send that up, yes, you are sending the file, but it's named with a string of characters instead of what you thought you'd name it. And I can show a little bit later why that's important, because you can actually, if you have the same file in two different locations, but it's literally the same file, like an image file, and it accidentally gets in two places, or maybe not accidentally, it'll have the same hash, and when you talk about it from two different directories, it actually only has to store that object once, so it's a little bit more space compacting. And both of them can say, hey, I need that file, and the other one says, hey, I need that file too. And that way you don't have to have the file twice. Works out pretty nicely. Even if the file has a different name, even if it's in a different directory, because the object is being hashed with just the contents. And the tree is what, well, I'm getting ahead of myself. Stay tuned, we'll get there. In the middle is kind of the fun part about Git, because you make changes, you want to save them to a repository, but not every time you make a change. Because usually you want to work through some things, add 5, 6 files, save them all, and then make that to be your change in the repository. So Git has this idea of an index. Its term has changed over to being called the staging area, or the index is often used. You'll see both of them. It's not something you can generally see. It's not something you tend to look at. It's something that you say, Git, I'd like to get these files ready to be committed, and it puts them in an index. Basically, it's just taking note of what you want to do. Kind of a visual representation of what I just said. You check out a project or you initialize it, you've got a working directory, you stage files into the staging area to get them all ready, and then you push them up. I'm going to go through this pretty quickly. So if we add a file to Git, it's not actually added to the repository by just using the git add. It's added to our index. It's not added to the repository until we commit it. Is this familiar to everybody? Good. Go a little faster. You can add multiple files at the same time and do them in one Git commit. Keeps things together when you have to change across files. So each commit plays one after the other, and as I said, you move along the branch as you grow, and each commit follows from one before it. And that's the simplest thing, because this is a linear branch. Git ships by, when you say git init, you have a master branch. The master branch is magical in no way at all. The master branch just happens to be what they called it when you get it. You can easily delete your master branch. Some people like to delete their master branch because they want to make sure they're controlling the workflow, and it's too easy to commit directly to master, so they don't want to have that be possible. So you can just remove it. It's kind of like in Drupal, you can remove user 1. We don't suggest it. It gets hard to go around some other things. There are probably better ways to protect yourself, but a lot of people disable or remove user 1 and set some other user as the administrative user. As long as your whole team and everybody who's going to use your project ever agrees to that workflow, it works out pretty good. But if you're ever going to make this public, the master branch is a pretty good convention to use because people expect it. So we're going to start with something called a raw build. I'm going to Git without ever having Git initted, without ever typing the phrase Git commit, without ever saying Git add. I'm going to build things up in a way so that we see what's going on under the hood. And we're going to do this by just making mkdir some things, and then hashing some text and putting it into the index, and then writing that thing into a tree, and then updating the tree into a commit. And none of that made sense, which is fine, because that's what the demonstration is about. And I'm going to show you a picture of Starry Night, because I swiped the wrong way. So what I have here, if everybody can see that hopefully, yeah, it's pretty, is a folder. The folder is empty. No magic, nothing up the sleeves. On the left-hand side, you'll see this directory 0 file. This is a loop just running on a while command that's doing a tree of that directory. So as I add things, you'll see them appear on the left. Nothing magic about my screen. I just have a split screen with a while command running in the back saying tree, clear, tree, well, tree, sleep, clear. And I can show you that as well. But, for example, I said one of the things you need to know for Git is to say, what makes a Git repository? An empty folder is not a Git repository. We know that. So it says, I don't I can't find a Git folder, so I have no idea where I am. I don't seem to be in a Git repository. So what do we need? It says, okay, well, we need a Git repository. We need a Git folder. You'll notice on the left-hand side now we have a .git folder. And I said, well, what do we really need? We need to be able to store objects, and we need to be able to store refs. And you need to be able to store refs as heads or tags. We'll just do refs heads for now. The -p just says you haven't created the refs folder. When you create the heads folder, create all the parents it needs, so make both of them. So now you'll notice on the left I have a Git folder with objects and refs and heads. And if you have an old enough version of Git, that's actually all you need. But about Git 2.7 or something, they decided, well, you really need to let people know where you're starting from. So you need a head file. You need a file in your Git folder that says head and points to whatever reference you're going to be working on. So I'm going to echo, and this is just, like I said, you'll never do this, but we're going to work off the master branch. Now if I just do this, it just spits out to this screen, but I'm going to actually just redirect that to a file called git head. You notice two things happened. One, I got a head folder file in my directory. Two, I have some command line, some command prompt magic going on that tells me what is going on if I'm in a Git folder. You can show that after if anybody'd like to talk about it, but it's called Powerline. But basically you saw that I'm in this netcam folder, and now it says, hey, you're on a branch called master, because it says, I understand now that Git is actually doing some things. So we have just created a valid Git repository out of shell commands. It's kind of a boring Git repository, but that's all right. So let's go ahead and make it a little bit more interesting. We're going to put something into this repository. And again, I have no file, but I'm going to echo, and I have on my clipboard some handy-dandy text. Bonus points to anyone who knows what this is from. But and what this command that I'm piping this text to is git hash object. So it's basically taking in some stuff, and it's going to write an object out to the command line. But to know what stuff it is, I'm going to just say, take it from standard in, from what I'm typing to you. And watch what happens on the left, and what happens in here. Watch everything. What happened was, it spit back this identifier. That's the hash of that text. That text hashes to that every single time. I could run it 100 times, it'll always be the same. You could run it, it would come out with the same exact hash. Because it's compressing and running an algorithm to generate the unique hash, and that's what that hash is. So if I had this text in 6 different folders, it would all hash to the same thing. That's what I was talking about being. So it stored it literally as a file in the objects folder. But it did something kind of interesting. It actually took the first 2 characters and made a folder out of those 2 characters, and took the rest of the characters and made a file out of those. Why does it do that? Well, it does that because most operating systems hate large folders. And by large folders, I don't mean folders with a lot of stuff in them taking up space. I mean with thousands of individual things in that level of the folder. And file systems deal much better if you break them down into subfolders and then put a tenth of your stuff in here, and a tenth of your stuff in here, and a tenth of your stuff in here. Because when it looks in a folder and it says, what files are in here, it can deal with 10,000. It can't deal with 2 million. But it can deal with saying, okay, I have 10,000 folders. Let me look in one of those. Okay, I have 10,000 things in this folder. And so it makes it a lot easier to manage huge numbers of files. And Git generates huge numbers of files, because every object is, every file, every version of the file, every commit, every pathing, which is called the tree, those are all different objects that are being stored. So everything in your Git history is stored as an object. And you can get a lot of them. So it just takes this hash and randomly just breaks off the first two characters and makes a folder out of them. So that since it's 0 through F, 256, hex is how they're hashing. You've got a maximum of 256 folders in your objects folder, and it just puts stuff in. It's kind of fun because you can go in and look in your Git directory and see these, and you can actually know what the Git hash is based on the directory plus the file.
So, quick question. So,
yes.
So, in the DD folder, you can have another object
Yep.
that has nothing to do with the ones that's in there, only that it begins with DD.
Yeah, and that's I shouldn't say it's completely random. You will think it's completely random which ones get bumped together because the hashing ending up starting with DD is like rolling the dice in 11 times and, getting one a certain number of times. It just happens. It happens based on the hashing algorithm, but it has nothing to do with what the file actually is or does. All right. So now that we have this hash, one of the nice things about Git is you can refer to hashes by the first, I think you have to have at least 6, but the first number of characters that uniquely identify it. So you'll often see, a hash being only like 8 characters long. And that's because, usually that's going to be enough. They make them this big so that there's guaranteed that it's really unlikely that you're ever going to hash things to the same hash without them being the same thing. It's 1 in a million chance to have them happen at the 6 or 8 characters. It's 1 in thousands of billions of trillions to have it happen at the other end. Little math joke there. Guy, worried about a bomb on a plane. He says, well, there's a 1 in a million chance that there's a bomb on the plane, but there's 1 in 15 trillion chance that there are 2 bombs on the plane, so I carry one. Doesn't work that way, but yeah.
Quick question there. So git hash object was the first time in all the demonstration that you used actually a git command.
No, I said status a couple times.
Oh yeah, okay, good. But the git hash object is probably also just made up out of already existing operating system calls.
Yes.
Okay.
So it's doing some zlib, I think, or G7. I don't remember what the compression and hashing algorithms it does to make both the file so that it's small. It's actually the file is smaller than the. So if I did something like cat.git/dd refs, objects dd. If I cat this thing, it looks like that. That's not what I typed in, but that's because it's been compressed. And then the hash is just to generate the identifier for it. So yeah, I actually thought about going into that in this talk, and then I was like, yeah, let's not kill everybody. Not at the first time. But what we do have is this identifier for this file that's now sitting out there. And we can actually see what the file is, and I'm trying to remember. Yeah. So if I git help cat file on that hash, and -p says print out the contents of the hash. So it un-gzipped it or whatever and spit it back out to me. You can also see information about that it's a blob, which means that it's something. It's not a tree, a hierarchy or a commit. It's one of the things called a blob. And then you can also see independently how big it is, how many bytes are in that. So those are things that Git uses internally, but that's another Git command, cat file, which basically says go grab an object and do things to it to see what it is. All right. But still no commit, and there's still no file. Like I made an object out of that text, but it doesn't actually exist as a file anymore. It exists as a gzip file back in my directory, but I don't have it in my working directory. I haven't checked it out. I haven't gotten it as a thing because A, it wouldn't know what file name to give it. It wouldn't know what directory to put it in. It wouldn't know anything about what to do. So what we do is we can add it to the index, which is that staging area, to get ready to put it, as a full descriptor into the repo. Yeah, so we're going to add it, and then we have to give it some information about where it's going to go. And one of the things that Git needs is the octal permissions on the file, just so it knows that when it checks it out, is it executable, is it going to be directory, is it symlinks, what is it? And so 644 might be familiar to people. 777 you hear, 755, those are executable. 644 just means the user can write to it, everybody else, the group in the world, can read it. I can do octal math for it if you want, but that's a different topic. The hash identifier is the other thing it needs. And then it needs to know, what do we want to call this thing? And we'll call this spiral.txt, because it was all about planet in the spiral of the galaxy. So when I do that, you'll notice that we got an index file. We got no more objects. We didn't get a file. We don't have a spiral.txt. But now the index knows that if we ever deal with this thing, we want to refer to it as spiral.txt. And the way to do that is to write out the tree. And we're going to write out a tree, which, remember, is the location of this thing in the world. So, the Dewey Decimal Number, the place it's going to sit on the shelf. When we do that, we get a new object. Should look familiar. So that object is a tree object. It's not a blob. And it basically says the same thing we passed in. Hey, make this blob out of this blob object, give it these permissions, and call it spiral.txt. Now the fun comes when we say git commit tree. We're going to take that tree that we just made, this thing, and we're going to commit it. And I'm going to do a little. We all know the -m adds a message to the commit. Commits needs messages. If I didn't add this, it would just open up VI, because that's my editor, and make me type something in. So this is allowing me to pass it in on the command line. Because a git commit needs a series of things. It needs a tree to know what files we're talking about. It can be multiple trees. And it needs a comment. And the rest of the stuff it's pulling from my global config, like who the author is, it can figure out the date on its own. But what my email address, all those things that we showed before, those are the other things that are going to go into the commit. We have a third object. So if we do the same thing, if we do git cat file, you'll believe me that if I check the type, it'll just say commit. When we show this, it says, okay, what is this commit? Well, it's a tree pointing to that thing, and here's the information, and here's the commit message. I'll let that sink in for just a second. Everybody good? So now I can say git status, and we have different things going on now. Because I added the file to the index, it says, hey, you have that change ready to be committed. The commit is there, this file is there, and it says, but you've deleted your spiral.txt file. And that's because Git is assuming that I started out with a working directory that actually matched my repo instead of from blank. So it's like, you've added this file, but I can't find it anywhere, so we're still empty, so it looks like you deleted it. Git doesn't know that I'm playing around inside. So it says, it feels funny. Don't do that. So it says, I'm ready to commit this new file. I don't even have it. But that created a commit. And that commit is now in my repository. And if I pushed this repository up somewhere, it would actually have that file. So I'm going to do something that I don't know that I've done before. Bear with me. I'm going to go to a completely different folder, and I'm going to say git clone. And I'm going to clone the Git folder, using, instead of from GitHub, I'm just going to clone it from locally. But I'm going to clone it, which is going to use the repository and then check everything out. And to be quite honest, I'm missing a command, and I can't remember what it is. But there's a command that I can use to actually get that object and make it show in my repository. I didn't write it down, and I'm hoping it'll come to me before I stand here too long, but that's all right. But trust me, it's up there. So if I look in the Git folder, even though, so Git init gives you more things. It gives you a config file, a description file, some hooks that are all, you'll notice, .sample, just so you can use it, some extra things about info. Same thing, it has the refs and heads, and it has my 3 objects in it. Because it does know about them, it cloned them, it just didn't know what to do with them because they're not checked out. Oh, I know what I need to do. We had originally specified that our head, the capital head, where we are right now, is pointing to refs head master. Right? Remember I did the echo refs head master to point for head? You'll notice that heads, there is no master. Ref heads master doesn't exist. Because there was no commit to point it to. It didn't know where to go to put the end of the branch. So if I'm going to go back to my original folder, just because that's a lot easier. So this is the original place we were. If I say, anyone remember what the last? Yeah, so this is the commit hash itself. If I say echo that string into git refs heads master. Now a new file, git refs head master, which literally it's just the string of text that is that commit that I want head to be pointing at. Now when I do status, oops, it doesn't have that part about you have an uncommitted file, because now it knows, oh, I've caught up to here, but oh wait, the file's missing. So we've gotten rid of that part about it saying something's wrong in the index. It's now caught up to where with that commit, but now it says, but I don't know what happened to the file. So if I just check out, it says you're supposed to be at this place. Checkout is just a normal command we use to check out a branch, but it can also be used, where we are. And you'll notice what just happened when I said, I'm at master, master is supposed to be this commit, check out this commit. It actually created a file called spiral.txt with my stuff in it. So this is the first time, that I've shown that my repo is correct. I want to try something here. Can you read that screen? It's a little tough with the dark, but... So this is the one that we made that was a clone. If I fetch from there, you can see what it did is it said, oh look, there's this new thing called master, because remember we had cloned before I had pointed where master is. Now it knows where master is, and now I can do a git status here, and it says, wait, you have nothing, no initial commit there, what's going on? And I can say git checkout. And it actually got the spiral.txt file and named it because it pulled down the rest of the information and was able, when I did the checkout, it actually knew, oh, I need to, from this commit, I'm supposed to have a tree. The tree is supposed to have a file called spiral.txt. Spiral.txt is supposed to be this blob. Let me pull it down and say what it is. Everybody good? Anybody think this is like just woo? But to me, what it really does is it let me see that a commit is nothing more than a pointer at some trees, and the trees are just locations for objects, and objects are just things in the repo. The nice thing is, when you use other Git commands like git reset, git revert, whatever you're trying to do, you're not losing all that data that you've done. Even if you can't find it, it's probably still there in an object, unless you do something called git cleanup. And git cleanup goes through all of your objects and say, there are no trees and no commits that point to this object. This object is just hanging out there. I have no idea what to do with it. I'm going to get rid of it because you can't find it and we don't need it. But it's still there. So for example, you may reset hard. Has anybody ever done a git reset hard and then been like, oh crap, everything I just did just went away? Because that's like, you throw things into the trash in your Finder, you can go get them out of your trash. You type RM on that file, it's gone. It just unlinked the sectors, and even though they're probably still written on the disk, your operating system has no idea how to go get them. That's what reset hard feels like, but it's actually more like you threw it in the Finder. You need to be able to know some of the internals to be able to go find that thing again. Okay, so one of the most fun commands that I use, on a daily basis to bail people out of weird Git situations is git reflog. And git reflog is one, basically, as you do things, it's keeping a log of all the things you've done. We've done them badly. Or I shouldn't say badly. We've done them inappropriately, with all these hash object, write tree commit, because that's not all that git commit. When I just use a regular git command, that's not all that it does. The other things it does is to write them into things like reflogs. So I don't have a reflog because I haven't done anything. But let me take another set of text, and I'm just going to, I'm not going to go through the whole bit again, but I'm going to put it into a new file called orbit. I'm going to add that. Okay, so you can see there's now an orbit file on the left, but nothing has changed in the repo. I'm going to add that file to my staging area. I'm going to commit it. So if I look here, git status, by the way, I feel like every git command should be followed by git status. Git commit, git status. Git add, git status. Especially while you're getting started, because then every time you do this, you see more about where you are and what's in there. And especially before you commit, you want to do git status. Because if you're the kind of person who does git add dot or dash capital A, like to add everything, you're going to get stuff you didn't mean to. You're going to get local config files. You're going to get password things that you threw in there temporarily. You're going to get a note that you saved that was for a totally different thing. Like, check it out before you do a commit, because here it's easy to get it out. We haven't done anything. It's sitting in an index. You commit it, you got more work to do to get it out. If you committed it and then pushed it up to an upstream repo, you got a lot of work to get it out of there. It can be done, and you got to make your whole team understand that you just rewrote history, and everybody's got to get back to 1985, and so that we don't, have what's his name as president? Wait. So here we are, and we do a git commit orbit added. So now there's a lot more things in my objects folder, because now we've got old commits, new commits, we've got trees for different files, we've got 2 different files, we've got a whole bunch of different things. But now I also have a reflog, because I did it the right way. And one of the things git commit did is it said, okay, the last thing you did was this commit, and you'll see that in the output, the git commit, this is the hash of the commit, and it exists in 8f, so it's this one right here. And it says, okay, I'm logging that the commit 8.1 was changed to master, so it moved our head along. So even though head used to be on 7.1 whatever, if I look at it now, it still says refs head master, which is right. But if it heads master, that is now the new commit, because when you do a git commit, it moves your head along. It keeps you going. You're not stuck. And it lets me do that, and it says it's adding this hash here, which was the hash of, it was actually the tree object for that. No, it's the parent. I'm sorry, it's the parent. So if I look at that, this commit, git cat file, that one is a commit from, that's the previous commit. So now if you remember my slide, we were here, we're now here. That's important because Git to know history needs to know where I came from. And this is how you branch, is basically you step back to this one and start a new line. So your parent is, a generation up, so your branches are cousins in a lot of ways. And not, continuing off the end. So we talked about what a tag is. A tag is really just giving, because those hashes are hard to remember, if you want to say, okay, this is the thing we're going to deploy to production today, and it's not something that we're going to keep adding on, like we want to fix this point in time right here, this is a way of saying, let's make this, I obviously made this slide when I was doing design for Drupal, D for D release on that hash. And that way, no matter what else I do on that branch, I can always refer to that one commit as being, D for D release. That way, if I need to deploy that to I can always get back to that particular commit and say that's what should be on production, or that's what I need to refer to in a way. But it is a single commit. It doesn't understand what branch you're on. It doesn't understand what you're doing, and you'll often see if I do come back to this and I say git checkout. The older commit gives me this scary thing saying you are now in detached head state. In other words, because now my head file isn't pointing at some branch, it's pointing at a commit. It doesn't say, oh, you're on master. When you add things, keep adding to master. It says you're right here and you're floating in space. And if you add this, I have no idea what to do with it. So you can't commit anymore. So you don't want to have a tag or a commit checked out in your local repo. You want to branch where you're on that tag or commit, but you still want to be on that branch, but just at a certain point in line.
So when you did that git checkout with that, it actually removed the orbit file from...
Yes, because this was the one before adding orbit, and checkout is a multi-step command that redoes all these things and rewrites your working directory. Because checkout means check out into my working directory the thing that I want. So let me get back to this and check out master again. Orbit comes back, we're all back and good. This is nice because like deleting that file, RM would have killed it. Just moving back in the tree, we still had it. This is where you can start to see what reflog gives us. Now I've got a couple of things in reflog, and it's telling me, okay, I was on, it started here. This was the first commit where I actually correctly set the head to be the right thing. So that's the first time it knows what to talk about. Then I moved master back to that commit, from master back to that commit, and then I did a checkout moving that commit to master. So instead of being on the detached head, now my head is attached to a branch again. Detached doesn't, it's scary and it's supposed to be, I think they do that on purpose. It means you're on a commit, but it doesn't know which branch, because that commit may be at the intersection of a bunch of branches, and it doesn't know where you want to go from here. So you gotta make sure if you're gonna make more commits, you gotta tell it. It's fine to deploy it to production, because production, you're not gonna be git committing on production, please. you're going to be doing all your work, Git committing, and then checking out in production as a nice static copy of it. So that's okay to be in detached head on production. All right, I got about 15 minutes. I'm going to talk for 30 more seconds, see if I can get half the room completely asleep, and then we'll see if there. I mean, I've been asking for questions the whole time. But the one thing I want to talk about is rebase and reset, because these are important commands that deal with commits. And I do have a little slide for that. So we understand branching. I'll do it quickly. If you're just committing, you can just commit your whole life through without ever changing branches, and it's this nice linear pattern. But if you want to try something and be able to throw it away, it's a lot better if you want to move to a new branch, because then you can let other people continue working on your repo. Your stuff isn't affecting them. You're trying it out. And then when you decide it's horrible, you can just delete it from ever having existed. And it didn't matter. It's like I never did that work, because I never gave it to anybody. Even though I was committing it and putting it in the repo, it basically just said, whoa, okay, that's horrible stuff, we'll get rid of it. And guess what? The objects are still there. The branch is gone. The ref log understands them. So you could actually go into the ref log, find out what just happened, and move back to right before you deleted the branch, and they'll all come back. The whole branch will just come right back. Really kind of handy there. Merging is the problem of taking two different branches and putting them back together. Because trees don't do this very often. Sometimes you'll see trees that grow back against each other. Git is made to do this because you really want to be able to take the branches and take all of these things and put them together. And a merge commit is basically putting the combination of all these things and saying, okay, we're here, but it's really the tree is this kind of like, remember the tree object. It now talks about two different paths and include everything within those. And at that point, I can get rid of the branch, because it's really, it can be thought of in a more linear fashion. Like the merge actually, if you think about it, brings them all up so that they're merged into one line. Rebase is a little different, and I love Rebase. Rebase is great. It's also what's, you'll often hear about the great debate about rebase or merge. A Git merge is often a rebase, and then adding the branch on it. I'll show why in a second. It's called a fast forward merge. If I have just this nice simple setup where I've got 3 commits, somebody else has done some commits and pushed them, I pull those commits down, but still my branch, this is what my repo looks like right now. A rebase literally moves the base of my branch to start from a different commit. So again, I had branched from this commit and started doing things. Remember, a tree object knows what a parent is, or the commit object knows what its parent was, and it was this. I'm now saying, okay, I don't want you to be parented from here, I want you to be parented from there. And as long as the commits are distinct enough that they're not overwriting the same text, like Git's pretty smart about saying not just the same file, but like the same pieces of the file. Git's like, okay, I'll do that. And it'll warn you if it doesn't. You've heard merge commits, merge conflicts, the scary things that we don't really want to get into. But this is what rebasing is doing, and it's exactly what it says. It's changing the base of your commit. It's changing where it's based out of. And as a project goes on and you've done stuff, and your stuff is your own stuff, it's not really changing anybody else's stuff, or parts that aren't changing. Rebase is great because now you can rebase, now it looks like one branch. And you can run all your tests against it, and you've got the whole history that you're testing against. But they're still in 2 separate branches. So I haven't merged yet. I've just done this, so now my branch includes all the rest of the things that happened while I was doing my work. And that's nice because now I could still delete my branch and get rid of it. I haven't put this back into the master branch, but I've included everything that happened in the master branch in my stuff. So you always want to git fetch, which pulls all the stuff that happened on the remote repo, and rebase before you say, okay, this is good, I'm going to commit it to the master branch. Because if you want to merge to the master branch, you have to do a three-way weird, like spaghetti. It's actually called, there's like octopus merging, and merging is hard. But if you can rebase and get your stuff so that it looks linear, merge just goes, okay, and says, we'll just consider that to have like it happened in real time. And if you rebase and there's no conflict there, your merge will never have a conflict. Woo! Wouldn't that be nice? I'm not going to go through remotes. Pushing, we all understand pushing. Fetch is important because you think about pull. We want to git pull. But a git pull does a git pull, a merge, and checkout, and like a whole bunch of things in one row. Git fetch just says go up to whatever repo we've got and make sure I've got all the objects and refs. And it pulls them all down and says, okay, we're set to go, but it hasn't done anything to you. And then you can say, okay, let's rebase against the remote. Let's pull all that stuff into my work or reset directly. We didn't talk about, I don't have reset in here. Reset is interesting. There are 3 things in reset. I'll try and go through them quickly. Git reset changes what's in the index, but not the working tree. Not your working directory. In other words, it doesn't mess around with your files, but it does change what's staged and what's not. So it's as if it goes back in time and gets it ready, as if you were going to do that commit again. There's a git reset soft, where it moves your head back to whatever commit you were talking about, but leaves your working directory alone. So now Git status will say you've got new files to deal with. Like they're not even in the index yet, but it knows that I don't match where I think I'm supposed to be. So Git reset soft will move your head pointer back to wherever you tell it to go, but it leaves the index and your working tree alone. Git reset with nothing is what I call a git medium, a reset medium. It changes the index but not your working directory. And a git reset hard does both. It changes everything. So basically you're like saying rewind the world and put me here, make my working directory look like this, as if I had finished the commit. So everything is clear. My git status says nothing to do, but I now look like I was at this point in time. So it's like, and I've done this many a time. Let's get rid of the whole damn folder, remove it, clone it again, and check this thing out because I can't figure out how to get here. Get reset hard is kind of that way of doing it. Bunch of things. Talking again, Git objects, blobs, trees, and commits. Your refs are just branches, which are called heads, and tags, which are just references to individual specific commits that don't change. The head file is where you which branch, which piece of thing you currently want to be considering your working space. You have a working directory, an index, and a repository. And the workflow between those is kind of like moving from dev to staging to prod. It's, you can undo, but once you're on prod, it's a lot harder. Any questions? Anyone think they're going to go try to git hash object something and see what it does? It's kind of an interesting, process, but hopefully this cleared things up for people. We got 5 minutes for questions. I'll be glad to take any if there are any, or we can end. Oh, I got a question.
Just coming back to the beginning, just how did you get the nice directory tree to the left?
Oh, sure. So I made a function in my bash profile, but this is effectively what it does. It says while loop, while true, so it's just going to keep happening. Clear the screen. Run a tree-a. So tree is a nice command. If you don't have it, brew install tree. Tree shows you your local. It's like doing an ls minus lr, but it shows it to you in kind of a tree structure. It shows you the directories. -A just shows you the hidden files as well as it's like LSA, shows you the hidden files as well as the actual files. So this file basically just clears that left-hand side, runs a tree, sleeps for a second, and does it again. So it's been doing it the whole time. There's also a watch command. Similar, but I found that watch, does these weird things to the screen and keeps flickering, and nobody can stand watching it because it actually is very distracting. And this one seems, this way seems to do it. And yes, stole this directly from what Tim Berglund did in his video talk that he sent there. He wrote this out. I just made it a function in my bash profile, so I can type wtree and it watches the tree. That's what I call that.
Question. Earlier you were talking about if you delete a branch, the objects are still in your repo
Yeah.
forever?
No. Remember, I also said that, so reflog will let you see them and do all these things until you do a git cleanup. Git garbage collection, GC. Git GC happens quite often in the background, whether you meant to or not, but it's like 30 days old things. It has a threshold where it's getting rid of stuff, but it'll just clean itself up as it goes. But what it looks for is objects and trees, tree objects and file objects that don't point to any, that aren't referenced by any commits, like even back up the chain. So there's nothing referencing them anymore that's viable. And then it'll say, I don't need these. And Git garbage collection will collect that garbage and throw it out.
And those objects that were abandoned in your local repo,
Yep.
they never go to a remote?
Unless you had pushed them, originally.
Okay.
So it's not like deleting a branch locally will delete the branch on the remote.
Right.
You have to tell the remote to delete the branch. It's easier to do that now. It used to be a really weird command to delete a remote branch. Now it's actually, you can just pass delete on the branch command, but yeah, that same thing will happen, and the remote will keep those objects along until it gets garbage collected.
And the garbage collection happens on its own, it's nothing you can...
Right, and you can schedule it, you can call it yourself if you want to clean things up. So like often somebody commits we have problems in hosting where somebody commits a 4 gig SQL dump file to their repo. And then they try and check it out and they're like, why is it taking so long? I want to get rid of that. Delete it, set your branch, commit, push. It still takes forever to clone my repo, but it's because the object is still there. So you have to go up and get rid of it somehow, either rewriting history or killing the branch that it's like doing something so that it's orphaned and then garbage collecting it and then force pushing that so that the remote knows to garbage collect it as well.
And
Yeah.
It's not going and finding the object and just deleting it from the remove command.
That'd be really bad.
Okay.
Because there probably are still tree objects, and there are probably still commit objects that reference that thing, and then it would be like all sad that it can't actually find that thing. Yeah.
With the rebase, you said bring it back up, it checks, make sure it's similar enough to actually bring it from the branch into the main line, or reset, sorry.
Oh, rebase. I said that.
But if there are multiple branches coming off, is it smart enough to look and say, hey, wait, there's other branches, you coming up is going to...
No, because you rebase to a branch usually.
Okay.
And you say, I want to go back to where this, no, you're right. You rebase to a revision. So yeah, it will look at that, but remember, the multiple branches, if they all have that same commit, then how they got there doesn't matter. You're at a state and time.
Gotcha.
Yeah.
Gotcha. Yeah.
And it depends on which branch you have checked out as for which way it could see the history, which branch you consider your parent. Yeah.
When you were
Mixed marriage.
when you were having your detached head, can you do a checker -b
Yes.
to make a new branch?
Yes.
So,
Yeah, exactly. So if I'm at a commit, it said you're in detached state. Let's see. I have it here. So if we check this out, it says you're in detached state. You can look around, make experimental changes and commit them. And it'll just kind of sit there and they'll be committed, but you can't do anything with them really. If you want to make a new branch and retain these commits, do so with the B command. And then basically it says, okay, we're going to start a branch from right here and continue on. And it really is not a good way to do it. You want to figure out where this commit came from and be on that branch and continue moving forward. Or be on the master branch at that point and start a new branch, or doing something so that it knows what to do. One nice thing is git branch -- contains, and a hash identifier will tell you which branches and states actually have that commit, so you could get back to it, at some point. It's a nice little history command. And we're done. Yes, run over my time. No more questions. I'm going to stop.